My name is Gaurav, and I'll be covering two things today. First of all, what we have done in container world, and again, to stress the fact that it's not about Hedvig containers, the real containers that we'll be talking about. And after that, I'll try to break our own system by kind of simulating the whole DC down scenario. So if you take all the storage nodes down in one DC, how do we hold up? And hopefully we do. So let's start with containers. Now, let me bring up the UI. So there'll be two things I'll be talking about in containers, which is Docker and Flocker. So I'm hoping everyone knows about Docker. Flocker may or may not. I'll describe what it is and what they do. And before I go there, just a quick overview of what this is. This is nothing but a Docker data center there that has been relatively recently released. And as part of the Docker data center, it's a Docker universal control plane. And that's what we use for creating volumes, deploying containers, and destroying them, and so on. So I always kind of find it as the equivalent of vSphere for containers, even though it's not as robust, but I'm pretty sure it will get there. So having said that, now let me first describe what's the problem that we saw people face when they're using containers with software-defined storage solutions, or any storage vendor for that matter. If I'm building a new modern infrastructure and I want to use containers and let's say some storage, software-defined storage solution, it's trivial to use volumes inside containers. So that's not the hard part. The hard part is if you want to develop a large scale application inside containers, if you want it to be highly available and you want your containers to be stateful when it comes to storage, that's when the real problem comes in. Now, as long as you're on the same node, there's no problem there. You can boot up a container, assign a volume, shoot it down, bring it back up. It's all good. The problem comes in when you move from one node to another and you want to make sure your storage goes with it. And that's where all the challenges come in, because there is no straightforward way to do it. There are roundabout ways to do it. Coming from most of the people, I guess, come from the, let's say, using VMs, running VMs in production, and that they want that kind of experience with containers. Now, there are two ways we want to solve that. Not that we want to solve that problem, is we want to make sure containers, whoever is using containers with our product, should be able to use it seamlessly. And the way we have done is by using Flocker and Docker plugins. Now, coming back to what Flocker is. Now, Flocker gives you these volume APIs that can be used inside containers, and they work with different orchestration tools like Kubernetes, Mesosphere. They have a plugin for Docker, and we started working with them as a partner for almost a year back. And the way it works is pretty straightforward, in the sense that when you want to create a volume inside a container, they issue a call to Hedvig saying, oh, go ahead and create a new Hedvig volume. So we internally create a Hedvig block volume, and then we use that as an iSCSI target to the node wherever the container is being deployed. And iSCSI initiator just picks up that device, and what Flocker does after that is they use that raw device, create a file system on top of it, and then mount it to whatever path that user wants to use inside the container. So that's how straightforward that is. Now, coming back to the problem, or the way Flocker is solving is, let's say you shoot down a container, or you stop a container. At that point, and you move it to another node. You want to start the same container on another node, and you want to make sure whatever storage you had, let's say a Hedvig block volume, moves with it. What Flocker will do is it will do a detached volume from node A to us first, and will remove that iSCSI target of the disk from node A, and then when it goes to node B, Flocker will issue a call, something like attach volume for the same disk or same volume, and we'll just mount it again. So the creating of file system part from Flocker point of view happens only once. So it knows in the whole cluster, for example, in this Docker data center, there will be a bunch of Docker nodes that will be treated as one cluster. So Flocker would know that this is what the same cluster is, the same volume that someone is trying to use at some other node, and they'll just ask us to, okay, go ahead and attach it again. So we'll just create a new iSCSI target in node B. So that's how simple as that is. Now, coming back to Docker, what we have done with Docker recently is we have created a new Docker plugin for Hedvig volumes, and there is no way to solve the problem that I just described kind of implicitly in Docker. So Docker doesn't issue anything like detach volume or attach volume. All they ask you is, hey, go ahead and create a volume and mount it at this location. That's all they care about. We don't know about the state of the container as has it been moved from node A to node B. It's just up to us to make sure it should work as seamlessly as it's supposed to. So the way we have solved that problem inside Docker is what we do is in the cluster, we create a NFS data store. That's step one. So very first time we get a create volume call, we'll create an NFS data store. And from there onwards, any volume that you create will be nothing else but a file inside an NFS data store. And then we'll create a loopback device on that file and then give that to Docker. And basically first time when you create a loopback device, we'll also create a file system so that Docker can just mount that volume as it is. So from there on, whenever they are trying to use the same volume in another node, all they need to do is just mount it, just because we'll be creating a new loopback device in node B, and they can just mount it because we had already created a file system. So that's how we have circumvented this problem, or kind of solved this problem, even though Docker natively doesn't allow us to do that. But this, in fact, kind of showcase another what we provide as a Hedvig platform. We can talk block, we can talk NFS in the same platform. So you don't have to go through different storage vendors to use volumes inside containers. You can use block, NFS, everything from the same guy. So, and again, it's pretty trivial here. I can even show you how this works. We can create any test Hedvig volume and just give the driver as Hedvig. You can provide different options. And the volume is created, and then whatever Docker DC allows you to do, which is creating containers, use the volume inside that, deploying, and so on. So in the interest of time, I'll skip that part and move into more interesting part, which is, let's say, trying to shoot down our own product by bringing down the DC. So just to set up what we'll be doing as part of this is we'll use a Windows VM and we'll run a video inside that, and we'll show you how where exactly that VM is mounted on which NFS data store, and how the data is replicated on which DC. So we have used NFS VM disk. So that's the data store we are going to use, and as you can see in the data center policy, it's data center aware, so SNC 1, 2, and 3. So there will be one copy of every data in each data center. And the VM I can use there's the VM that I'm going to use, and I can just quickly show where it is residing. So its boot disk is residing in NFS data store, and this is the file that .vmdk file that it uses to do actual IOs. And in the UI, I can show using browse. Here is the folder for that VM for which all the files are in there, and this is the .vmdk file there where the IOs will go in. So I'll start a video, and I'll take the help of Chris to make sure the video, just to make sure you can see that video is running all the time, hopefully. And there you go. So, and this is another plug for our OpenStack integration. So there's the demo video of that. There you go. So the video is running, I hope. Is it? Yep. Okay, cool. Let me make this one. Yeah, it is. So now I'll shoot down a data center, and you can see from the cluster watch, there are 3 data centers, SNC 1, 2, and 3. So I'll choose SNC 2. And as you can see, these are the nodes which are part of this SNC2. There we go. And our UI should detect that in few seconds that all the nodes are down. As you can see, the video is still playing. And you can also look at Chris if you want. Not at Chris, but the video. Yeah, so there you go. So it has detected all 3 nodes are down, shown as clear red, and then the video is still playing. So as we all know, it's not just that it's doing reads as part of that, it's a file system on top of our board disk, so it does writes as well. So there are reads and writes going on, and the whole DC is down, and it still is going on. So that's the same point is being reflected here, which is if a DC is slow or down, that doesn't affect the IOs in our system. And in this particular case, what will happen is for the period of time when this DC is down, we would have recorded all the writes that have failed for the nodes in this DC, and we would have recovered as soon as it comes back. So this kind of stresses the flexibility of architecture and kind of performance.
Just for clarity,
Yes.
show that the vDisk has no caching or anything enabled.
That's true. That was important.
People don't think we're pulling the wool over there, right?
Yeah, there is no edge caching. There's nothing. Cache is not enabled, so nothing is being cached at the proxy. So everything is doing the whole round trip.
But on the data center, is it also possible to stretch your VMware environment with it?
Yeah. Hopefully, if I've got time, I'll whiteboard that for you. Yeah. We've got customers doing that today.
Okay. So will it choose, or is it proxy-wise? Will it use the right proxy, or you always use the local proxy, right? From a VMware host perspective, and it will choose the right path to the data, right?
Exactly.
It uses a local proxy, and if that local nodes are down, local storage or same data center nodes are down, it will figure that out and send the reads and writes to the other data center node. So proxy has that much smartness built in.
Okay.
So it will do that. Okay. Cool. So another plug. So we have a booth in DockerCon as well next month. So if any one of you is there, please stop by.